Okay, hello everybody. This is the first solution from quiz 3. So there were actually 3 problems. You can see we're being told we should use integration by parts on these. So that's what we're going to want to use. We're also told we can use the tabular method. All right, and that's actually what I'll do in this video since it's just so much faster and more convenient. And I suspect that most of you would like to see more examples of that anyway. So this first one, you'll notice we have a 5t plus 1 cubed term, a sine of 2t term, and if we want to use integration by parts, which you'll remember you have this integral of u dv is uv minus the integral of v du formula, then you need to pick a u and you need to pick a dv. My general rule, right, is you pick something for u that you want to differentiate and something for dv that you don't mind integrating. And, well, here's one thing we might notice. We have a polynomial raised to, okay, it's raised to a third power, fine. When we differentiate this, it's going to become a smaller degree polynomial, which makes that a good candidate for our u. So let's give that a try. Let's take 5t plus 1 cubed, that's going to be the u, and then sine of 2t, that's going to be our dv. So we're going to differentiate, and let's see, now when I do that, the 3 is going to come down, but I'm also going to get a 5 because of the chain rule. So I'll get 15 5t plus 1 squared. And over here, when I antidifferentiate, I'm going to get a half, let's see, antiderivative sign is negative cosine, okay, of 2t. And now I can sort of see ahead what the pattern is going to be. I'm going to keep differentiating until I get to 0, and then I'll just antidifferentiate as many times as I differentiated. All right, so the next time I'm going to get 30 times 5, which is 150. Okay, now it's times 5t plus 1 to the first. Okay, I'll antidifferentiate. That'll give me a negative a fourth sine of 2t. Okay, differentiate again. And, well, this time, right, this is the first power. So this is really just going to be the derivative of 5t plus 1, which is 5. 5 times 150 is 750. Okay, over here, I can antidifferentiate. And, an antiderivative of sine will be negative cosine, so I'll finally get rid of that negative. So I'll get positive 1/8 cosine of 2t. And then finally, one more time to get down to 0. And I'll have 1/16 sine of 2t. All right, so now this uv, right, this was our u, this was our dv. So this is the v, that's the u. I multiply diagonally. All right, and I do that all the way down. And you remember we get our alternating signs. Okay, so to write down the antiderivative now, let's notice each one of these I multiply, and I'll either get a cosine or a sine. So let's group all the, say, cosines together. So this will equal, let's see, how many cosine of 2t's do we get? Well, first thing, let's see, we're going to have a plus minus, and on this one, just a plus. So nothing clever to write there. So let's see, negative a half, and then 5t plus 1 cubed. So negative a half, 5t plus 1 cubed. And then the other one, okay, I'll have 150 over 8 times 5t plus 1. So 150 over 8. Of course, I know that simplifies, but I don't really want to do it. All right, so that's all the cosine of 2t's. And then let's find the sines. So we get sine of 2t times, all right, so this one we get minus minus is plus, 15 over 4 times 5t plus 1 squared. So 15 over 4, 5t plus 1 squared. And then this one down here we have a minus, and we'll get 750 over 16. Again, that does simplify a little bit, but I don't want to do it. Okay, so there we found an antiderivative. All right, next one we want to do is the arc cosine function. And this, at least originally, may not look like an integration by parts problem because the typical thing you're looking for, right, is a product of functions, but here you don't really see one. However, this falls under the, hey, I don't know how to find an antiderivative, but I do know how to find a derivative, case of integration by parts, right? Which immediately tells you what your u should be, right? You don't want to integrate this, so don't make that your dv, make this your u. So let's give this a try. Our u will be arc cosine of t, and our dv will just be 1, right? It's a missing 1 that you can't see there. All right, so a derivative will be negative 1 over root 1 minus t squared, and an antiderivative will be t. All right. Now, at this point, we don't really want to differentiate this anymore. In fact, what we want to do is combine these together, because if I put this t on top, that's actually going to become a substitution problem. So the tabular method extends a bit, where what we do is we go into a box, which allows us to replace these with anything we like as long as the product is the same. So for instance, I could leave the negative 1 over here and move the denominator over to the right and get t over root 1 minus t squared. Okay? So I can do that in the box. Now, I know when I go to do this substitution, I'm going to want to let u be 1 minus t squared. The du will then be negative 2t. So I kind of want this to be negative 2. So what if I put a negative 2 up here? Well, I could do that at the cost of, well, let's see, moving that negative over and dividing by 2. Because now if I multiply, you'll notice the half and the negative 2 become a negative 1 times t over root 1 minus t squared. The same thing as if I multiplied here. Okay, so that's just a little clever shortcut. All right, well, the derivative of a half, that's easy. That's 0. Now I need an antiderivative of this. So let's just do a little scratch work. If I let u be 1 minus t squared, du would be negative 2t dt. And so if I integrated negative 2t over root 1 minus u squared, t squared rather, dt, I can replace this now. Look, the negative 2 dt becomes du, and the root 1 minus t squared becomes root u. Or, I can never think about it as a radical, right? So I'll rewrite it as u to the negative 1/2. So now I know, okay, I add 1, that'll be 1/2, but then you have to divide by 1/2, which is the same as multiplying by 2. Okay, so our antiderivative will be 2 times the square root of 1 minus t squared. So I can put that over here, 2 root 1 minus t squared. So now I draw my lines, and remember, never any lines inside the box, because you weren't doing anything in there, just reshuffling your integral. And so my antiderivative will be t times the arc cosine of t minus a half times 2, hey, those cancel, and then root 1 minus t squared. Okay. And so one could differentiate to check this. Okay, so just one more. So this time we have what looks like a little more usual integration by parts situation. We have a function, the sine of t, times the hyperbolic cosine of t. So again, I got to pick a u, I got to pick a dv, but here it's pretty easy to both differentiate and integrate sine as well as cosh. All right, you got to remember the derivative of cosh is sinh, right? Hyperbolic sine. Also, the antiderivative is sinh. So it doesn't really matter a ton which one we do, so I'll just do them in order. Okay, so let's see. If I take a derivative, then the derivative of sine will be cosine, and an antiderivative of cosh will be sinh. Okay, so I would get a new product, and I don't know how to find an antiderivative of that either, so we keep going. Take a derivative of cosine, and you'll get negative sine, and a derivative or an antiderivative of sinh, and we'll get cosh. And now I notice that if I multiply, I actually, other than this minus sign, get back the original problem. Sine times cosh. Okay, so I go into the box knowing I'm going to pull the I trick. So I'll leave the negative 1 on the left, move the sine of t over. Okay, we double check. Is the product the same? Sure. This was negative sine of t, cosh of t, negative sine of t, cosh of t. Right, so this is fine. Derivative of negative 1 is 0. And an antiderivative of this, well, it's the problem I'm trying to solve in the beginning. Let's call this I. Right? An antiderivative is I here. Okay, so draw our lines. Again, no lines inside the box. Plus, minus, plus. And so what do we conclude our I is equal to? Well, let's see. We get sine times sinh. So sine of t, sinh of t. Minus cos times cosh. Minus 1 times I. So, okay, so minus I. All right, and so the way the I trick works, we can add minus I to both sides. All right, or plus I should say, to both sides. And so we'll get 2I is equal to, well, this other stuff, right? I can quickly copy it. Sine times sinh minus cosine times cosh. Of course, my goal isn't to get twice I, it's to get I. So I will divide by 2, and that will give me I is 1/2 times sine times sinh minus cosine times cosh. And there we go. So that we could copy paste up here under our integral equals, all right, let's put it on up there. Okay, I guess we don't need this I here, right? Get rid of that. So there we go. Of course, one can do this using the long form, right? Using your u's and your dv's. But what you'll find over time is that you'll make more mistakes doing it that way, and it just takes a lot longer. So it takes a little work, of course, to learn this tabular method, but once you do, I promise you it'll be well worth your time.